Okay, so the enrollment problem. This is Module 4, Investigation 9, problem number 3. In 2009, the enrollment at Mainline High School was 1,650 students. Administrators predict that the enrollment will increase by 2.2% each year. So this 2.2% here, this is, well, that's not going to be helpful. This is the growth. The percent change, right? So it's increasing by 2.2% each year, so the percent change is 2.2% in the positive. So determine when the enrollment at Mainline High School is expected to reach 2,600 students. Well, so if we wanted to figure out how it's growing, that's an exponential model. They told us that by saying it will increase by 2.2% each year. So we could say that the enrollment is 1650, that initial value, times 1.022 raised to the year, right? So I'm going to use t for the time that's going by in years. So this 1.022 comes from 100% of the enrollment, the 1650, plus another 2.2%. So that's 102.2% of the previous year, or 1.022. If we wanted to figure out when it's going to be 2,600 students, we could say 2,600 is equal to 1650 times 1.022 raised to the t here, and we could solve this. So there's a couple of ways we could do this. We could solve this by using a logarithm, right? So we could use, well, first we'd need to get it into a form where we could use a logarithm, right? So we would need to say 2,600 divided by 1650 is equal to 1.022 raised to the t power. And then we would need to transform that into a log base 1.022, right? So we've got a 1.022 base exponential that changes to a 1.022 base logarithm. The input becomes the output becomes the input, and then we have equal to t, and we can calculate that and figure out what that is. On Desmos, incidentally, let's go over to Desmos. On Desmos, incidentally, if you go over to functions and you choose miscellaneous, logarithm is at the bottom here. So I can go 1.022 of 1650 over 2,600. No, other way around, isn't it? Is that right? Yeah. So we've got that, and so that's about 20 years, maybe closer to 21 years. So this is between 20 and 21 years away. Let's kill this off here. Let's go this way. So between, oh, I guess I should put that answer in here, huh? So this would be equals 20.89 or thereabouts. So this would be between 20 and 21 years after 2009. So during 2029, or at the beginning of 2030. And the reason I say it that way is because if it's between 20 and 21 years, we can't say 2029 definitively, because at the beginning of the 2029 school year, we're going to end up with less than the 2,600 people we were looking for, and so we want to make sure that that we're extending all the way to 2030 if we're talking about the beginning of the year, or saying it's sometime during 2029. Either of those answers is perfectly reasonable. All right, so with this guy here, part B says, suppose Mainline High School requires 5 teachers for every 65 students. How many teachers are required if the student enrollment is 2,600 students? Well, that's pretty simple math, right? So we can say if we've got a 5 to 65 ratio of teachers to students, right? So that's, I'm going to put capital T I'm going to put E here because enrollment is what I used before for E. That's the number of students, right? So I can use that again, just so I'm not adding in another variable. What that means is I've got, if I cross multiply, I've got 5E Yeah, 5E is 65T, or another way to say that would be to say E is equal to 13T, and which would be a simpler way to do that. So if I want to know if the student enrollment is 2,600 students, how many teachers do I have, right? I could do that a couple of ways, but the way I've gone about it right here is to say 2,600 is equal to 13T. Yeah, so I would need to divide by 13 on both sides, and I would end up with 2,600 divided by 13 is 200 teachers. So T is 200. Okay, so I've got that. Now this last question is kind of the sticky wicket, and it may be where you guys got stuck during class on Thursday and Friday of last week. It says define a function f that gives the number of years since 2009 in terms of the number of teachers employed by mainline high school. So it's important that we note that up here we defined T, this lowercase t that's in here, we defined this as the number of years since 2009. We didn't define that when we were there, and shame on us, or me, but there it is, right? So what we want is we want the number of years as a function of the number of teachers. Well, we define the number of teachers as the variable t up there. So that's what we're looking for, is we want to know what is this function, what is the rule for that function. Well, to do that, we need to think about how we defined it in terms of the enrollment, right? Could we do it in terms of the enrollment? We can totally do that. So let's take a moment and let's give ourselves a place to write that. So I'm going to put that over here. So we had two things up here. We have E is equal to, in fact, I'm just going to copy and paste. We've got this guy here. Whoopsie. What are you doing? Stop that. We've got this guy here, and we know that this is true. We know these two things are true, and so we can take this information and do some things with it. So let's take a moment and think about that. So if we replace E with 13T, we have something that looks like this. We have 13T equal to 1650, whoopsie, 1650 times 1.022 raised to the t, little t, as opposed to big T. I realize I've just done that anyway. And we can solve this this equation for t in order to find the rule that we want over here in the same way that we solved this function up here. So we can go through and we can say, okay, let's divide both sides by 1650, just as we did before. 1.022 raised to the t, and then we can convert this to a logarithm, right? We can say this is going to be then, where's my log? There it is. I can say that this is going to be log base 1.022 of 13t over 1650, and that's going to be equal to t, right? Just lowercase t. So I can take this rule right here. Oopsie. That's weird. I can take this rule right here, and I can substitute it in for the rule that was missing here. Okay, fix some of my syntax here. Oh, that's not what I wanted at all. Hold on. What did I do wrong over here? Oh, I see. This is in the wrong place. That's better. Which has nothing to do with the math and everything to do with the syntax. I'm clearly losing my mind. Okay, so there's the rule for that. All right, so that takes care of this problem. We have now a rule that produces the number of years given the number of teachers, right? There it is. Okay, I'm going to end this one